For this video, we'll be talking about section 7.2, solving systems by substitution. This section is actually broken up into 2 days. So we are going to start with obviously the day 1 version of these notes. It's the first 2 pages of the packet you were given. So we have a quick little review here. You can solve systems of equations more than one way. Previously, we learned to solve the system by graphing. We had 3 possible answers. Please list and explain. The first one was one solution where we read it as an ordered pair x comma y. This would be when 2 lines intersect at one point. The second answer that we had was no solution. This was when the 2 lines were parallel, therefore they never intersect or touch. And then the last option we had was infinitely many solutions, and this was when 2 lines coincide. And if you forgot what the word coincide means, that just means that there's one line directly on top of another line. Just to review really quick as well, if the 2 lines were parallel, they had the same slope but different y-intercepts. If the 2 lines coincided or they were directly on top of each other, then they had the exact same equation. They had the same slope and the same y-intercept. Just another reminder, when we graphed, and it was infinitely many solutions, we put double arrows on the line to show that there were 2 lines there. Okay, so to review this vocab word here, a set of 2 or more equations with the same variables is again called a system of equations, which is what we are still focusing on today. For the substitution method here, we have a few steps to pay attention to. Step 1 says, when necessary, solve at least one equation for one variable, meaning isolate a variable. You'll notice that there are some hints about what to do if you actually have to do this step, which we will talk about obviously when we get to those problems. So before I read any of the steps, we're going to go ahead and look here at numbers 1 and 2. So looking at number 1 here, step 1 says isolate a variable. Well, I see that this y has already been isolated. So what I'm going to do is I'm going to draw a box around whatever y equals. Now, whatever y is equal to, I'm going to take that box and substitute it in for y in the bottom equation. Think if I originally, and you don't need to write this part down, I'm going to erase it here quickly, but if I told you that y was equal to 2, you would take 2 and substitute that in for y right here. So what we're doing is the exact same thing here. So if y is equal to 2x, I can take 2x and put it in for y down here in the second equation. So I'm going to erase this really quick. And then I'm going to go ahead and start plugging that in. And when I do that, everything else has to stay the exact same. So I have 7x minus, but I'm not going to write y anymore. I'm going to plug in my 2x or substitute in my 2x. This is now step 2, substitute the resulting expression from step 1 into the other equation to replace the variable. Then we actually have to solve. So then everything else stays the same. I'm just plugging in that 2x for y, which I drew an arrow to, if you see that right here. For these notes, I would definitely recommend that you write the same things that I do on your paper. So if I draw a box, you should definitely draw a box. If I'm drawing an arrow, you should definitely draw an arrow. This is probably going to be a pretty tough lesson, so I would make sure that, you, again, like I said, you're writing everything down. Make sure you take really good notes while you watch this video. So once I actually substitute that expression in for y, I'm going to go ahead and start solving. So I see that I can go ahead and combine my like terms. So I have 7x minus 2x would give me a 5x equals 15. Divide both sides by 5, and I get x equals 3. Once you do that, we need to go to step 3 now. Step 3 says substitute the value from step 2 into either equation and solve for the other variable. So I'm going to take x equals 3, and I'm actually just going to plug it into my box because y is already by itself, so I know that it's 2 times whatever x is. Well, if x is 3, then y is equal to 2 times 3. So I'm going to go ahead and write that down, though. So y equals 2, and then I'm substituting in that 3 here. So then I have y equals 6. Therefore, my final answer would be 3, 6. We have to write it as an ordered pair because, again, if you remember from the top of your notes, it says that you can solve systems of equations more than one way. So theoretically speaking, I could have given you a graph on number 1 and said put both of those in slope-intercept form and go ahead and graph them, and the intersection point would actually be at 3, 6. So we're going to go ahead and move on to number 2 here. When we do that, again, we're still back onto step 1 here. So isolate a variable. Well, I noticed that actually both of them have isolated variables. So I could either put a box around 3x or I could put a box around negative x minus 32. I'm going to go ahead and write a box around this one, this bottom one. So negative x minus 32. Again, it's everything after the equal sign that gets the box because that's what y is equal to. So then I can take whatever y is equal to and plug it in for y. A really, really, really common mistake that kids make. And again, this is one of those things, don't write this down. I just want to show you something. If you were to draw an arrow that pointed to the x instead, you would get y equals 3 times negative x minus 32, and then you'd have to actually solve this. Well, you can't actually solve this because there's an x and a y in the problem. You need it to be that there is just one variable that you could get by itself. So if you look at number 1, when we substituted in, I had all x's, I was able to solve for x down here. In this case, I have x's and y's. I will not be able to solve this problem. So I'm going to go ahead and erase this really quick. Again, please, 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 please make sure you didn't write that down. I'm also going to erase that purple arrow there because that was not supposed to be there. So please make sure you have on your paper what I have on the screen right now. And then I'm going to go ahead and actually plug this in. So then I start with my negative x. Oops, I got on my highlighter here. Did not mean to do that. There we go. Negative x minus 32. And then I copy everything else down, equals 3x. And then I'm able to go ahead and start solving this. So then I'm going to add x to both sides. So then I have negative 32 equals 3x. Divide both sides by 3. And we get x equals, oh, we made a mistake. This should be a 4. I don't know what I was thinking. So going back up to here, 3x plus x should definitely have been a 4x. So then we would divide on 4 on both sides. And then we get x equals negative 8. There we go, much better. Now again, once I find x, I'm going to plug it back into my box up here to find y because my box is equal to y. So then I have y equals negative, and then I'm going to put negative 8 in parentheses. Please remember that this negative does not have anything to do with the negative 8. It is separate. And then I have minus 32. So then 2 negatives here would make a positive. So that would give me a positive 8 minus 32. Therefore, y would have to be negative 24. And then I write my final answer, as always, as an ordered pair. So negative 8 comma negative 24. X always comes first, then y for your ordered pair. So that would be the process for substitution. We're going to go on to the second page. We have a few more examples to do together. Okay, now we have examples 3 and 4 here to look at. So again, step 1 is isolate a variable. In this case, I actually noticed that I have y isolated as well as x. So really you could draw your box on either side and it would work all the same. So I am going to show you in this example that it's okay to draw a box around y. So now we've isolated x. So then I'm going to draw my box around y. And then again, whatever my box is equal to is the variable that I'm going to plug it in for. So if x is equal to my box, then my box has to go in for x here. Because again, I want all the same variable when I plug everything in. So I have 2y equals, I'm plugging in y, and then plus 3. Notice I'm using parentheses again when I plug things in. Make sure you're doing the same. So I look at this and I see that I have all y's, so I'm able to go ahead and start solving this. So then I would subtract y from both sides, and that gives me y equals 3. And in this case, there's nothing else to solve for. So then I'm going to go ahead and draw an arrow to my box. Again, I always like to plug things back into my box. It's the quickest way to find your final answer. So then I have 3 equals x. Well, in this case, I could just flip this around and say that x is just equal to 3. So then my final answer, written as an ordered pair, would be 3, 3. And again, if you were to graph these, this is exactly where they would intersect on a graph. So looking at number 4, again, step 1, do we have an isolated variable? In this case, again, yes, we do. So my y is my isolated variable. So then I'm going to go ahead and draw my box around everything after the equal sign. So I just want to reiterate again, on number 3, the only reason I drew a box around y was because x was isolated. In this case, you're not going to draw a box around y because x is not isolated. You can only draw a box around the opposite side of whatever is isolated, meaning that's what your isolated variable is equal to. That is going to get plugged into whatever my box is equal to. So since x plus 7 is equal to y, I can plug that in for y. So then everything else stays the same, x plus, and then I'm going to plug in x plus 7. and then equals 17. My plus sign got a little messed up there. And then I'm going to go ahead and start solving here because, again, I have all x's, so I'm able to isolate x and get x by itself to find what x is equal to. So I'm going to go ahead and combine my like terms here. So I have 2x plus 7 equals 17. You'll notice that even though we've been using parentheses, they're actually not necessary. They haven't been, at least so far, because there's nothing to distribute on the outside of them. But I do want you to make it a habit that we do definitely need to make sure that we're using parentheses, because eventually we are going to have to start distributing. And then if you don't have those parentheses, you will definitely be getting the wrong answer. So if I continue solving here, I have subtract 7 on both sides. 2x is equal to 10. And then I'm going to divide both sides by 2, and x is equal to 5. Once I find that, again, I'm going to plug this into my box. So I have y equals, this would be 5. Oh, I need blue, plus 7. So then my final answer here would be y equals 12. Well, that's not my final answer. My answer for y would be 12, but then my final answer would be 5, 12, written as an ordered pair with parentheses and a comma. Okay, we have 2 more for day 1, and then we are all done with day 1. So looking at number 5, I have to have an isolated variable. In this case, I actually do not have an isolated variable. So if you read through your hint on step 1, it says when both equations need to be solved, pick the easiest one. You're looking for coefficients of 1 or -1 when possible to avoid working with fractions. So what I mean by that is this y right here has a coefficient of 1. That is going to be the quickest variable to get by itself. Because if you were to try to get the x by itself on the bottom, you would subtract y from both sides. So if I just wrote this down here, you would have 2x equals 9 minus y if you subtracted y from both sides. And then when you go to divide by 2, 2 doesn't divide evenly into everything. So then you're going to end up with x equals 9/2 minus y over 2. And then you're going to have to draw your box around this and try to plug in fractions. It's possible, but it just gets very messy. And for some people, fractions are a lot harder to work with. So we would like to keep it as simple as possible. So I'm going to go ahead and, again, erase this because this is not the route that we're going to take. We are going to look for whenever there's a variable that has a coefficient of 1, that's going to be the one that we isolate. So instead of subtracting y from both sides like we just talked about, I'm going to subtract 2x from both sides because I want this y to be by itself. So then I'm going to go ahead and get y equals -2x plus 9. Now that I have y isolated, I can go ahead and draw my box. Notice I did not draw a box until I had my isolated variable. So no boxes can be drawn unless you actually have an isolated variable. Now, the other thing that we have to pay attention to is we use the bottom equation right here to get to this point right here. Since this is a system, you have to still make sure that you use both of your equations. So since we use the bottom to isolate the variable, that means that I have to plug it into the top equation to make sure I get the correct answer. So I'm going to take my box and plug it in for y. So when I do that, I have 7x minus 8, and then in parentheses, -2x plus 9, and then the rest of that equation is equal to 112. So then if I go ahead and start solving this, in this case, the parentheses were absolutely necessary. We need to distribute this -8 to the inside of the parentheses. So I have 7x plus 16x minus 72 is equal to 112. I'm going to go ahead and combine my like terms. So I have 23x minus 72 is equal to 112. And then add 72 to both sides. And I get 23x is equal to 184. Divide both sides by 23. And we get x is equal to 8. And then again, once you find this, we go straight back to our box and then figure out what y is. So y is equal to -2 times whatever x is, but now we actually know that x is 8, so I'm going to plug that in. And then plus 9. So then when I start simplifying, I have y equal -2 times 8 would be a -16 plus 9. My answer for y would be -7. So then if I wrote that as a final answer, it would be 8, -7 in parentheses with a comma in between the two numbers. So this one was definitely a longer problem because we had a lot more solving to do once we plugged in or substituted in that expression for y. Now, when we start looking at number 6, something I want you to take note of, in this bottom equation, there's actually no y. So whenever you see that there's a missing variable, it actually is going to be in your best interest to go ahead and get this x by itself. So I'm going to add 2 to both sides. And when I do that, I just automatically get x equals 2. So you'll see that we ended up at the same spot right here. So we actually got to skip the first step of substitution. So now we're down to here. I'm just going to go ahead and take my x equals 2. Since I used the bottom equation, I've got to plug it into the top equation to find y. You also have to use the top equation because that's the only equation that has the y, and that's the missing piece that we still need. So I have 2 and then minus 3y equals 14. And then I'm going to go ahead and subtract 2 from both sides. Negative 3y equals 12. Divide both sides by negative 3. And then I have y equals negative 4. Final answer would be 2, negative 4. And that is it for your day 1 notes.